Hazard, risk and safety. We all hear these terms on a daily basis. So-and-so a chemical, physical or a biological agent poses a risk. This or that product is a hazard, or behaving a certain way is unsafe. A lot of the time, hazard and risk are freely used to mean the same thing. However, they are not. Hazard is the potential to cause harm. Risk, on the other hand, is the likelihood of harm in defined circumstances. But what does this actually mean? Let's look at two examples. First, potassium dichromate. It sounds scary, and it is indeed a hazardous substance that is both toxic and carcinogenic. It is used in some cases to analyse exhaled breath for alcohol. For this purpose, it is sealed in a tube. Therefore, although it is intrinsically a hazardous substance, if used and managed as described, it presents little or no risk to people or the environment. Now, let's look at the opposite case. Flour would not be considered by many to be a hazardous substance. However, if a baker were to be exposed over a period of time to airborne flour, he or she could develop dermatitis, conjunctivitis, rhinitis, and even asthma. So even something that is considered a low hazard can present substantial risk, and vice versa. Risk is always a probability, influenced by the level of exposure. To evaluate the risk, we have to take many factors into consideration. How, where, how much, and how long one can be exposed to the hazard are all things to be taken into account. Toxicological research can map the potentially harmful properties of a product, be it chemical, physical, or biological, and it can also set a limit under which exposure will have no effect. Based on this research, a risk can be calculated based on frequency, conditions, and length of exposure. However, some types of risks are hard to quantify, either because of the complexity of a system, like in the case of climate change, or because we still lack some of the tools to measure it, like in the case of nanomaterials. When there is no consensus on the level of risk, policymakers sometimes apply the precautionary principle. When sufficiently established elements suggest that an activity is seriously expected to potentially produce irreversible damage to health or the environment, measures should be taken even if the definite proof or the causal link is not yet formally established with absolute certainty. It is best to err on the side of caution. Nevertheless, the precautionary decisions should remain proportional to the potential but uncertain risk and be re-evaluated when new data become available. Indeed, the proportionality principle is and should be at the base of most legal thinking. Now, how can we manage a risk? Risk can thus be managed by limiting exposure to a danger and by the adoption of risk reduction measures. Prevention might be a better idea to reduce risk. For example, driving has been made safer by speed limits, the use of seatbelts, bumpers, airbags, driver assistance systems, etc. But what is considered safe? Acceptable safety levels greatly depend on where you are on the planet, culture, socio-economic criteria, and the sector. Similarly, the safety limit adopted for a pesticide like DDT has to be balanced with its importance in safeguarding health or food resources in some regions of the world. For each specific case, an acceptable safety level has to be determined. This is thus not only a technical but also a political decision. Even if the previous steps are logical, what is considered safe has to take into account the perception and acceptance of risk. These tend to be emotional and rational at the same time. For example, flying is commonly considered a greater risk than driving, although all statistics point to the contrary. Moreover, once a perception of risk sets in, it is very hard to change, even if all evidence points to the opposite. For example, fear can be fueled by debatable science and poor or even sensationalist interpretation of a study by the media. A very limited study that indicates that substance A could be harmful to mice and would merit further research quickly turns into a "Substance A kills" headline. Once fear sets in, even if risk is not proven, the precautionary principle is often pulled out of the hat. In a nutshell, risk and perception of risk are not always aligned. This can make political decisions difficult to make. In these cases, it is especially important to base them on facts rather than on opinions. These facts can be gathered from scientific reports published by reference institutions, but these reports are often written in a technical language that is not accessible to anyone but the specialist.